Hello everyone, welcome back to IMSC 685. Talk about K-means clustering algorithm. First we go to our Canvas main page, go to the course module. I want you to download a Jupyter Notebook section. Actually over here is the fifth K-mean clustering with a Python Jupyter Notebook. So please download that one, and we give you some guidance in this lecture and show you how everything is done. So once you download that, you should be seeing something like that. We start with an empty Jupyter Notebook to begin with, and let's talk about the step. First, initially we're going to import some visualization, okay, MachineLearning, and import Seaborn, okay, and since this is a Jupyter Notebook, so my Matplotlib should be inline. Okay. So this is the first part. Next, we're going to create some random data using scikit-learn. Scikit-learns a dataset portion. So we're going to import from scikit-learn dataset. Import, let's see, make blub. Okay, and then we're going to start creating some data. Oops, sorry. Let's do this. Data portion. Okay. And we call the data equals to make blob. Using n samples equals to 200. Let's do that. And n features equals to, let's do 2. Okay. And centers equals to 4. They have 4 centers. Okay. Looks like 4 centers. Okay. Cluster standard deviation equals to 1.8, for example. Random stay equals to arbitrary C value. Let's do this. 685.11, which is randomly assigned it. Okay. Whoops. Okay. So we created data. Let's take a look how the data looks like. Okay. Scatter plot. I'm using my data, and actually just need the zero part of them. Okay, and data actually 0. Actually, and C equals to the data 1, which is the color map is based on the cluster that belongs to in. Then we do the C map, give him a pretty map color. Let's do rainbow. All right, for example. So this is how the data looks like. Okay, 4 different blob right here and 4 different cluster. So now we're ready to using the KMeans algorithm to figure out what they are. Let's do a little bit zoom in. So first we from sklearn, we do import KMeans algorithm. Okay, looks like this is, sorry. Based on cluster library. Okay, so whoop, KMeans, sorry. And define the cluster, we call it KMeans, equals to KMeans, using n equals to cluster equals to 4, as we talked about before. All right. Whoops. Let's do this. Okay, cluster equals to 4. And the next, we're going to do the fitting. Sorry. Let's make sure this is KMeans dot fit based on data 0, which is the feature part. Where do I have that? It should be down here. Okay, so figure out the KMeans algorithm is done. So let's take a look how the result. So KMeans cluster centers, how the cluster centers actually are located. Oh. Okay, these are actually the coordinates of the centroid for each one of the cluster, and also we can take a look how the KMeans algorithm determine their labels. Okay, these are the cluster number, each one of the data point they belongs to. So the next portion, we're going to do the plotting of comparison between the cluster, the result, and the original data, how they be different. So let's do this. Let's do a plot, subplot. So let's do and share y, okay, value equals to true, okay, and then I'm just going to enlarge the figure size. Equals to 10 by 6, so it's kind of longer figure, and okay, we've done that. So we create 2 figures already, and it looks like that. Next we're going to do is doing the first one. Set title. This one is KMeans result. And the next one will, and then we plot it out. Scatter, actually, or data, 0, portion, and this is the coordinates of the data for the scattering plot. Okay, and then the color map I'm going to use, the color color I'm going to use is the KMeans result. Okay, so I'm going to using the result above to plot the color for each data point, and then I'm going to do the CMap equals to rainbow as well. Okay, see. Going to do the similar for the original data set. Just copy and paste what I have. So the second subplot we're going to call original. Data set. And the second one I'm going to do is using a different color map, which is using our original generated part as our. Let's take a look. What do we do wrong? Okay, we're missing a angle bracket here. Same as here's. Okay, we generate the 2 plot, and as you can see, they actually pretty similar. Please ignore the color matching. That color means very different, meaningless in this case, because it just represents they belongs to different cluster number. You can see over here they got cluster, over here cluster, and over here they are 4 different cluster exist. But you can see that there's the K-mean algorithm actually probably missing some of the data point in the regions. Actually, this point it got cluster to this cluster, and some of the data point over here as well. So we can see that there is a slightly difference. Please notice that this K-mean is unsupervised training method. Training method is almost like an optimization algorithm. It don't have any target value. It calculates based on his criteria itself, and to figure out which cluster each data point is belong. Okay, let's try this with changing the number of a cluster in our K-mean. Okay, for changing it to 2 cluster and rerun everything. And you can see that how K-mean thinks this 2 cluster belongs to. And we can actually keep increasing, changing this data to 3. And this will be the 3 cluster K-mean think they are. In this case, we can do 4, and actually we keep increasing this to 8 cluster, and this is what the K-mean think the 8 cluster looks like. So I want to emphasize one more time, the K-mean algorithm is an unsupervised training algorithm. They don't require any labels value or the target value to perform the training and the testing. It figured out itself. Here, since we generate this data randomly on our own, we're lucky enough to have the labeling data to compare with. Okay, so we conclude this lecture.